less, a point of light. But in the mid-70s, Dale Cruikshank and colleagues attached cameras with infrared filters to a telescope at Kitt Peak.
Detectors or sensors had been improved, and larger telescopes had become available. Well, we did that work in 1976 and found evidence for frozen methane on Pluto's surface. It was several years later that we found the evidence for the other ices.
In 1978, astronomers Jim Christie and Bob Harrington analyzed new plates taken at the U.S. Naval Observatory in Flagstaff. Christie noted an elongation to the north of Pluto. 1 month later, the bump had disappeared. From this and other evidence, they concluded that Pluto, like Earth, had a moon, Charon. From eclipses between Pluto and Charon occurring in the 1980s, astronomers calculated that the moon was almost half the size of its parent body, so large that both objects spin around their mutual center of gravity, outside Pluto. Pluto and Charon were the first double dwarf planet combo discovered in our solar system. Using the basic physics of their orbits and the distance between them, astronomers could calculate their mass and size. Pluto was a little smaller than Earth's moon, about 1,500 miles in diameter, and had only 1/10 its mass. Between 1985 and 1990, astronomers were in luck. As Pluto and Charon orbited their mutual center of gravity, each passed in turn in front of the other. The so-called mutual events allowed astronomers like Mark Bowie to capture the changing patterns of light. Patiently, Bowie created a map of Pluto. Pluto turned out to have one of the two most contrasty surfaces in the entire solar system. In the mid-90s, Bowie and Alan Stern used the Hubble Space Telescope to make the first direct images of Pluto's surface.
And it's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system previously.
In 2005, Hal Weaver and Alan Stern used the Hubble for another close-up look at Pluto and Charon. They discovered two small, dim moons where only Charon had been seen before. Now we know from Mark Showalter's work that there are two more moons, making the current total of 5, and that Pluto is a genuine mini-planetary system. From its size and orbit, astronomers estimated that Pluto is perhaps 70% rock and 30% ice. That makes it one of the largest of a whole new class of objects, the ice dwarf planets, making up what's known as the Kuiper Belt. This region is named for Gerhard Kuiper, a leading mid-20th century planetary astronomer. Kuiper suggested that the solar system didn't end with Neptune and Pluto, but that there should be a disk of other worlds beyond them. In 1992, from a mountaintop in Hawaii, David Jewett and Jane Liu found the first Kuiper Belt object. They were using new and highly sensitive CCDs, like the sensors in a modern digital camera. But their technique was essentially an updated version of Tombaw's work. Take carefully registered images of a patch of sky and see if anything moves against the distant stars. This one, QB1, did just that. It was only a few hundred kilometers across, 10 times smaller than Pluto, but still huge compared to a comet. Since then, teams of astronomers have found around 2,000 KBOs. Informed by cutting-edge astronomy, but with a fair dose of artistic license, let's take a trip through this third zone of our solar system.
We used to think of the solar system consisting of two different types of planets. The planets we call the terrestrial planets, which are Earth-like planets. That would be Mercury, Venus, Earth, and Mars.
Next out, the asteroid belt. Fragments of worlds smashed to pieces by gravitation and collisions. Then come the 4 gas giants. Jupiter and its moons. Saturn with its magnificent rings. Uranus, also ringed. And Neptune.
And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper Belt objects, this is kind of almost a third type of object.
So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what outer parts of the solar system are all about.
By July 2015, we'll know for sure what Pluto and its moons look like. And that will provide breakthrough information on all those other ice dwarf planets, the most numerous planetary objects in the entire solar system that make up the Kuiper Belt. Actually, the Kuiper Belt is more like a donut, bulging up above and down below the ecliptic where most of the planets move.
It's kind of like the asteroid belt, but much bigger. It has hundreds of times more objects in it than the asteroid belt.
Let's now visit 5 named KBOs in the exact positions they'll be in on July 14, 2015, the day when New Horizons flies by Pluto. Quaoa was one of the first Kuiper Belt objects discovered. It's about 1,000 kilometers in diameter, a reddish world, covered in water ice, methane, and ethane. And like many KBOs, it has a tiny moon of its own, Waywhat. Up above and down below the plane of the solar system, numerous KBOs have been flung about by Neptune's gravity. This region is known as the scattered disk. One of the largest of these KBOs, Eris, is close in size to Pluto and is made of rock and methane ice. Astronomers categorize KBOs by the tilt of their orbits relative to the plane of the solar system. And one of the more highly inclined orbits belongs to Makemake, named for a Hawaiian creation deity.
Some of these have methane or water ice on their surfaces. Some of them just seem to be covered in some brownish gunk. There are gray objects out there. There are brown objects out there. There seem to be distinct populations.
Some of them seem to be very spherical, and so they probably have warm interiors, and then others are peculiar shapes which suggest they're very cold and strong.
Perhaps the most bizarre and unexpected KBO is Haumea, a KBO shaped like an American football, made of rock and ice. It's white with red splotches and orbited by at least 2 moons. One of the strangest orbits of any KBO belongs to Sedna, discovered in 2003. Its orbit is the most eccentric of any KBO now known, bringing it as close as 76 AU to the Sun, but then carrying it outward to 936 times the Earth-Sun distance. Sedna's strange 11,000-year orbit seems to link it to an even vaster cloud of objects, ready for exploration by future generations. The Oort cloud is an immense icebox of long-period comets, from 10 to 100 times more distant than the Kuiper Belt, surrounding all the known worlds of our solar system.
There's a real record of the early history of the solar system out there in cold storage at the edge of the solar system.
This is what was left over. Pluto is the first member of that group.
But to begin humanity's exploration of the Kuiper Belt, you first have to get to Pluto. And that means getting a mission approved, a spacecraft designed and built, and delivered to the launch pad on time. And none of that was easy.